Alright, welcome back to my channel. So in this video, I will explain about the integration of the logarithm functions. Before we start, let's make a quick review about the formulae that we learned before. So in the first formula I want you to memorize is actually when we integrate ax to the power of n with respect to x, we will just copy back all the things and the power increased by 1, right? And we will divide by the new power. A is a constant, so it is something like 3x, 5x, 6x cubed, then and 7x, 32 power of 32, then we can imply this formula. And don't forget to add a plus c at the end of the answer since it's indefinite integrals. So second, the formula we have learned is actually k ax plus b to the power of n dx. And when we integrate it with respect to x, we will get back k is a constant, so we copy back, where here is a linear function. What inside the bracket is a linear function. So the linear function will copy back as well, ax plus b, and n, the power is increased by 1. And we divided by the new power and multiply with the what is the f prime x. That means the f prime x is actually equivalent to a, right? So it's a plus c. And hence, from the second formula, we already derived the third formula, that is when we have f prime x and fx power of n dx, and we will get fx n plus 1 and over the new power, which one is n plus 1 n plus c. And this is our expansion from the second formula. Since we are already dividing here we have the f prime x is actually like here I add the a here, so it's cancel out each other, so we didn't appear for the third formula. Alright, so however, if you look carefully, these three formulas, after we get the integration part, you must see n plus 1, n plus 1, n plus 1. The n is restricted that n cannot be negative 1. If n equivalent to negative 1, your denominator equivalent to 0. When you ax plus n, anything you divide by 0, you get infinite. So you will get an invalid answer. So how we do when the n equals to negative 1? That means the reciprocal come into play, time to row, and we will explore the logarithm integrations. Alright. So let's see the formula for the logarithm functions. So for logarithm functions in differentiation, we already learned that from the previous videos. I hope you still remember when we have y equivalent to ln x. When we differentiate it, if you want to know the derivation, you can always look back my videos and know how to derive these differentiations. And you divide the x, you will get 1 over x, right? So it's the same thing as I said. The integration is completely reverse of the differentiation. So when you integrate this part, you will get back ln x. That means we derive the formula. When we integrate 1 over x dx, we will get ln x plus c. Where we put a modulus at the x to make it the x is positive, to show the x is positive. In STPM, you need to add a modulus sign, okay? So this is the formula that you need to memorize for formula 4. Alright. But this x is only restriction for the x. Cannot be used. That means it's not convenient to use because it's only x. Let's say I can 1 over 3x, then I can only use. How about I have 1 over 3x squared? This formula is invalid. So next, we learn another formula of logarithms. So from the chain rule, we learn in the differentiation part. Chain rule from differentiation. We already learned that when y equivalent to ln, and here is fx. In differentiation chapter, we learned that divide dx. If you want to know derivation, always look back my videos, and you can get f prime x over fx, right? So now it's completely reverse it, you will get the same thing. So derive our formula 5, that is when we integrate f prime x over fx to dx, you will get ln fx plus c, right? So it's the same thing. Okay? The only thing you need to add is a constant and a modular sign for the indefinite integrals. Alright, so let's look at an example here. So where we integrate 4x plus 1 over 1 plus x squared. So if you look like this, it's definitely don't panic, okay? So you can see, if you see, here is 1, the denominator part is actually x squared, and here is actually x1. The difference, you must look at the strategy, the difference between difference of power of variable x between the numerator and the denominator is 1. And you can imply this formula, right? Because why? It's actually x over x squared, and you will get x to the power of -1. X to the power of -1 is actually n. It's actually n, right? It's actually n. Alright, so if it's n, then n cannot be -1. When you get n equals to -1, that means you need to imply the logarithm. You already know. Okay? So now, how are we gonna do these questions? So if I were you, I would just write y equals to 1 plus x squared, and you try to differentiate it. dy dx, here we get 0, and plus here 2x, and you get 2x, right? So what you need to think about is the formula 5. You need to memorize, okay, I know that this is f prime x over fx, dx is equivalent to ln fx plus c, right? So now you already have the fx here. Here is your fx. You need to create your f prime x, since the difference is only 1 degree. So how can my 4x change to 2x? I need to change my 4x to 2x. So very easy. You just need to change 2x. You write what you want here, and you multiply with a 2. Is it become 4x already? It's the same things. Okay, so 1 plus x squared dx. Then you can take out the constant. It's actually 2x and 1 plus x squared integrate with respect to x. So now you already have the f prime x here, and here is your fx. Here is a differential of the fx, right? So now you can straight away imply the answer. 2 ln, the constant must copy it back, and ln fx is 1 plus x squared and plus c. Here is your answer. It's very, very easy. Alright. So if you don't believe this answer, you can try to prove. So I make a proof. I use a substitution method. As I said, substitution method is always the most direct method. Substitution method, I use the proof. And yes, I copy back the same question for x, 1 plus x squared dx. Alright, so if substitution method we let you equals to 1 plus x squared, and du is equivalent to 2x dx, and dx is actually du over 2x, and you are making the same thing for x here and u here and du over 2x, and you can realize that x can actually cancel out each other, and this one can be 2 become 2, and you can get 2 over u du, right? And it's actually, you take out the constant, it's actually 1 over u du. As I said, what is this? Refer the formula. Formula 4. 1 over u, 1 over x is actually ln x, so you get ln u. So it's actually 2 ln u, and add a c here. Okay, so what is your u? You need to change back in terms of x. So it's actually 1 plus x squared. So it's actually 2 ln 1 plus x squared plus c. So you can see here and here, the answer is the same answer. So that's why we prove the things you need to memorize these two formulas, where integrate 1 plus x, 1 over x dx is actually ln x, and f prime x over fx dx is actually ln fx. This one is the reverse of the differentiation. If you forget, you just think about differentiation and you know the integrations. Okay, I will see you in next video, and I will explain about the further of logarithm functions and exponential as well. Okay, thank you for watching.